Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us. The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sunlight in but keep some of the heat from escaping like the glass wall of the greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric CO2 hasn't reached today's level in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. While the rapid rate of climate change is caused by humans are also the ones who can combat it. If we work to replace fossil fuels with renewable energy and reduce the emission from the point sources, which can reduce the greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change. Our approach is to mitigate the CO2 emission from its source points by using carbon capture and storage technology, or known as CCS. This technology holds a promise of trapping up to 90% of CO2 emission from power stations and industrial sites. CCS involves three main techniques, including post-combustion, oxy-fuel, and pre-combustion. However, this study is focusing on post-combustion method by using adsorbent to absorb CO2 from the flue gases of the power station. Among those available adsorbent in market right now, our study is focusing on the modification of the existing carbon-based adsorbents, which is activated carbon nanofibers, or known as ACNF. Briefly, ACNF is the combination of activated carbon and nanofibers that possess properties of both materials, such as high in-surface area and wide distribution of pore volume, for enhanced CO2 absorption performance. The physicochemical properties of the ACNF were further improved by incorporating nanofillers or additives such as graphene-based materials into the structure. Graphene was selected in this study due to its high surface area, thermal stability, and also high conductivity, which significantly affecting the features, properties, and performance of the GACNF composites. The main highlight of our research is the addition of graphene-derived rice hulls into the ACNF, which is the very first study so far that extensively used these composite absorbents for CO2 absorption. Moreover, the successful synthesis of graphene from agricultural waste not only benefits this research, however, indirectly helps the local paddy industry to solve the rice hulls disposal problems, in which they can turn their waste to valuable products. Due to high concentration of CO2 in atmosphere, the market needs also increase in order to mitigate the greenhouse effects. Since 2019, the absorbent market analysis reported that the global absorbent market keeps on rising and it is expected to increase by 30% in 2026. Moreover, the market need in Asia-Pacific regions for absorbents seem to be as high as North America by 2026, which shown our products could have better market in the near future. As CO2 is a colorless gas, in this absorption study, we have used nitrogen dioxide to replace CO2, as both gases possess almost similar properties.